On with our 5.3 lesson, we are on to synthetic division, which is another way to divide out our polynomials. But note that synthetic division only works when our divisor here, the first term, has no coefficient, or the coefficient is just 1, should I say. So it only works if you have like x minus something or x plus something. It doesn't work if there is a term in front of that. If you wanted to get it to work, so say that this wasn't x minus 2, if it was like 2x minus 4, we'd have to divide it by 2 to get it down to x minus 2, and we'd have to divide everything here by 2, which, as we can see already, this one would be a fraction. We don't want to have to do that. We don't want to have to use all those fractions. So in this case, it will work because it's already in the form where there's no coefficient. The coefficient is just 1, but remember, from like moving on, anytime that you are your divisor has a coefficient in front of the first variable, you can't use synthetic division. Once you've determined that you can use synthetic division, though, again, it's just another way of dividing out these polynomials, and it actually makes things fairly easy. You make the kind of box shape there, a backwards L, and draw a line underneath it. And I'll tell you what all of these are for in just a second here. When we're looking at our divisor, we have x minus 2. So we look at the opposite of whatever we have here. So if that is a negative 2, we would have positive 2 put into our box. From there, we look at the coefficients of all of our pieces in our dividend. So if we look at our first one here, the coefficient is 1. If we look at our second one, coefficient is a negative 4. If we look at the third one, it is a positive 6. And we look at the last one here, it's another negative 4. So the way that synthetic division works, we drop down our first one right away. So we know that right away our first number that we're going to use is 1. Now, the next number we write down is we take our 2 multiplied by that 1, and that's going to give us 2. That'll go right there. We'll get rid of that there. So now that we have 2, we just take our negative 4, add it to 2, and that's going to give us a negative 2. Now again, we'll take our 2 from over here. 2 times negative 2 is a negative 4. We'll take our 6 minus 4 becomes 2. And the only thing left again is our divisor of 2 over here, times by this 2 becomes a positive 4. Negative 4 plus the positive 4 here is just 0, which is good because, again, that would be where our remainder goes. And we don't have a remainder on this one. We don't want remainders. In this case, now that we have all of our numbers, those are just going to be our different x values. So this first one would be x to the 0th value, or you can notice that that's just going to be our constant. This is going to be our x to the first value. This is going to be our x squared value. So in the end, you would write your answer as, you could either say 1x squared, or you don't have to say the one part, you just say x squared minus 2x to the first power, or just 2x, and plus 2, which is the same as saying 2x to the 0th. So our final answer is just x squared minus 2x plus 2. Goes a lot faster than long division, but again, it only works if your divisor doesn't have a coefficient in front of the x term. So let's try it one more time, see if we can get it to work the same way. We'll make our little box, make our line. Just like before, the number that we were looking at is negative 2, so if we want the opposite of that, put a positive 2 here. Now we just look at all of our coefficients out in front. So we have a 5, a negative 13, a 10, and a negative 8. First thing we do is drop down the 5. 2 times 5 is 10. Negative 13 plus 10 is negative 3. 2 times negative 3 is negative 6. 10 plus 6, or 10 minus 6, or plus negative 6, is going to be 4. 2 times 4 is 8. And a negative 8 plus 8 is just going to be 0, which is good. We like it when that one is 0. So again, this is our x 0th term, this is our x to the 1 term, and this is our x squared term. So our final answer becomes 5x squared minus 3x to the 1, or just 3x, plus 4, or 4x to the 0th, and there is no remainder. So this is our final answer. Moving on to situations where you have a coefficient other than 1, the first coefficient right here. Now, in your notes, I think it says that it's easier to use long division on these, but again, let me tell you that the synthetic division, the method, only works when x, or the coefficient in front of x, is 1. So the only way to do it would be you'd have to divide everything by 2, and we'd get a bunch of fractions, which we don't necessarily want to work with. So for this one, we have to go back to using our long division process, our long division algorithm. So 2x plus 1 is our divisor on the outside, and our dividend on the inside. We have 8x to the 4th. Now in this case, we don't have x cubed one, but it is technically an x cubed place, so we'd have to say plus 0 x cubed, because there are no x cubes, but there's still an x cubed place value, minus 4x squared plus x plus 4. And now from here we just go about it the same way we would any of our other long division processes. We have 2x going into 8x to the 4th. To get 2 into 8, multiplying by 4, and x into x to the 4th would be x cubed. So our first term there that we're looking for is 4x cubed. 4x cubed times 2x is going to be 8x to the 4th. 4x cubed times 1 is just going to be 4x cubed. I guess it would be plus there. But remember that we are using subtraction here, subtracting these out, so this becomes negative, this also becomes negative. So when we figure this one out, 0x cubed minus 4x cubed becomes a negative 4x cubed. 8x to the 4th minus 8x to the 4th is just 0, so we don't have to worry about that one. We do, however, have to drop down our negative 4x squared. And now we are looking at how 2x goes into negative 4x cubed. Well, that would be negative 2x squared times, because negative 2x squared times positive 2x gives us a negative 4x cubed, and also negative 2x squared times this positive 1 is just going to leave us with negative 2x squared. Now again, remember, we're subtracting this one, so this has to become positive and this has to become positive. So when we figure that out, our 4x squared plus 2x squared becomes negative 2x squared, and our negative 4x cubed plus 4x cubed becomes 0. And we need to drop this x down, it's positive. So now we're looking at how 2x goes into negative 2x squared. Well, that would be negative x amount of times, because now when we multiply our negative x by 2x, that gives us a negative x squared, and our negative x plus 1 is going to give us, or negative x times positive 1 is going to give us a negative x. Again, we're subtracting these, so this becomes positive, this becomes positive, and this becomes 2x, and this one stays as 0. And we have to drop down our 4, positive 4. Now we're looking at how 2x goes into 2x. Well, that one would just be 1. So 1, I'm starting to run out of some space here, drop this down. 1 times 2x. So I'm going to do this in a different color, a purplish color. 1 times 2x is 2x. 1 times 1 is 1. Remember, we are subtracting here, so these both become negative. This then becomes 3, and 2x minus 2x is 0. So in this case, we are left with a remainder of 3. So we would want to say that that one becomes plus our remainder over our divisor plus 2x. So plus a 3 over 2x plus 1. So in the end, our final answer, go up here and circle it, is this 4x cubed minus 2x squared minus x plus 1 plus 3 over 2x plus 1. Kind of a long one. Again, doing the same kind of process, we're going to use long division to find 4y to the 4th minus 5y squared plus 2y plus 4 divided by 2y minus 1. So we have to set it up with our divisor on the outside and our dividend on the inside. Oh, actually, I already screwed up there. Remember, this, we have our y to the 4th power here, so we need to fit our y to the 3rd power. There are none of them, so we do still have to include that. But then we minus 5y squared plus 2y plus 4. So from here we start how we always have. 2y going into 4y to the 4th is going to be 2y to the 3rd. 2y to the 3rd times 2y is 4y to the 4th, and 2y to the 3rd times negative 1 becomes negative 2y to the 3rd. Remembering this is subtraction, so that's a negative, that's a positive. This becomes 2y to the 3rd, and 4y to the 4th minus 4y to the 4th stays as 0. So we are good to go there. Drop down our negative 5y squared. Now we're looking at how 2y goes into 2y cubed, and that is just going to be y squared. So when we take y squared times 2y, we get 2y cubed, and y squared times negative 1 is negative y squared. Remembering that this is a subtraction, so that's minus, that's plus. This is going to become, in the end, keep this as a green one, this is going to be negative 4y squared, and 2y cubed minus 2y cubed stays as 0. So from here, this is where we drop down our plus 2y. And now we're just looking at how 2y goes into negative 4y squared, and that's going to be negative 2y. So, moving down a little bit here, negative 2y times 2y is going to be negative 4y squared, and negative 2y times negative 1 is going to be positive 2y. Now, when we take it as a subtraction problem, so this has to become plus, this one becomes minus. 2y minus 2y is 0. Negative 4y squared plus 4y squared is 0. So we are left with just 0 as our value there. And 2y goes into 0 0 times. 0 times, actually I suppose I could have done this in purple again. 0 times 2y is 0. 0 times negative 1 is 0. And if we were to drop our 4 down, remembering this is a subtraction problem, 4 minus 0 stays as 4. 0 minus 0 is just 0. So now we are left with a remainder of 4, but remember we don't want to call it a remainder of 4. We'll add it so that our remainder is over our divisor. And so we are left with this. So our final answer in the end will become 2y cubed plus y squared minus 2y plus 0, or we don't even need to mention that part, and just say plus 4 over 2y minus 1. So this in the end would be our final answer.